Thank you. Happy to be here. Today we are going to talk about multimodal data, about video, audio, PDF files, and how to deal with these new types of artifacts in our new AI universe. Two subjects will be covered mostly, like efficiency, how to do this efficiently, and how to handle this complicated structure, because those files hide a lot of insights, and sometimes it's very challenging to represent and deal with this not massive, but complicated data files. So a little bit about myself. Thank you for the intro, but on MLOps side, I was working on DVC, data version control. It was my open source project, later the company, but now my focus changed to multimodality, multimodal data, how to deeper understand all the insights from the multimodal data. So today we will cover a few subjects. First of all, the data and how to deal with this multimodality. Sometimes people call this heavy data. We will talk about efficiency, different types of tricks, because this data is special, it's new, and it requires a new set of tricks that some team might be haven't used before. Quickly cover visualization, and then complex data structure, and how to look zoom in inside the file themselves. So heavy data, that's a keyword that I've seen, I heard several times in the past years. If you remember, or maybe you read the term big data, right, which was popular about 15-ish years ago. It's about high-scale data processing, data analytics, unstructured data, right? Tabular data inside data warehouse, or maybe even Excel. Today, world changed quite a bit. So all the companies already super efficient in this area. And now with the LLMs, AI, and new models, enable the whole new universe in the data space. It's video, images, PDF files, sensor data, MRI scans, whatever artifacts you might have, right? And most of the data in the company is in this format that's really, really hard to understand with the traditional tools. So those data is big, right? We are talking about megabytes or gigabytes per one single file. Processing, it's tricky because SQL doesn't work, data frame doesn't work, DBT is not helpful, so you deal with the Python, you deal with LLMs, you deal with the models, and how to organize the process, how to be efficient is an open question today for the whole industry. It's slow, and it requires a deep context, because when you get a one video file or clip or MRI scan, you might have a lot of different questions to this file, right? And depending on your question, it can provide you more information. So it's a context of working with these artifacts is very important part of the process. So we cover a different modality a little bit here and there. And how about the audience? What modality you usually work with? Who works with video data? Anyone here? Okay, one person, video data. Two, good. How about PDF? One, two, yeah, that's a lot more. How about biomedical formats? Scans, 3D, DICOM and such, no? All right, and structured data, who works with the traditional structured data? One, two, three, okay, good. All right, in this multimodal data world, what is interesting, people usually work with multiple modalities at the same time, right? So, and I'm sure you will find some practices useful across the modalities. And what also interesting today, some people just live in this multimodal universe for a whole life, right? If you deal with video, if you deal with audio, that's just your world, right? But what is interesting, business today are getting more insight from their PDFs, documents, and such, right? And they want to get value from these artifacts. And many companies today build RAG application today, but they understand that this not the quality that they need, right? Sometimes they're a little bit too shallow to answer actual deep questions. And the way how people deal with the heavy data and this kind of like a new analytics, if you wish, with LLM, that's the way how you can get way better quality of your answer. It's kind of like, if you say like, if before it was like a big data analytics, today we are getting to the stage of like AI analytics, if you wish, with this like a heavy artifacts and such. All right, we start with a simple subject about like the efficiency, because it's slow, first of all, right? Sometimes you deal with hundreds of thousands, sometimes millions of files. Each of the files is heavy. You need to like apply models. You need to apply LLMs. You need to apply Python. And a few challenges here beside the size. So data is changing. Processing is failing all the time. And sometimes you just need to understand what happens before. So for example, a few months ago, I was talking with a company, with AI team in the company, and they were building AI application on this like a PDF use cases. Hundreds of thousands PDFs, Excel files, plus structured data. They wanna group this by the companies and build the whole agentic workflow to kind of provide insights about the companies they analyzed, right? Hundreds of thousands of documents. If you, they built, of course, like a whole agentic workflow with not like a one single prompt, but like a whole process, whole application. And if you run from the beginning to the end this process, it will take almost a day to execute. A lot of compute, because they use like a few machines, plus millions of tokens, right? Super heavy process. And what is interesting, it doesn't work from beginning to the end. First problem, each week they're getting more and more documents, right? This week, like 3 companies, like a new company came. Next week, 20 companies, right? And they need to update this constantly. It needs to be incorporated in their production use case, right? Processes fail. They were saying it was not a single time when all these 100,000 documents were processed from beginning to the end. It fails because LLM fails, because their agent messed up, because bugs in the code, infrastructure just failed, right? One of the machines was shut down, right? And so what are you doing? Like, are you executing this from beginning? I mean, probably not. You like waste already like a few millions of tokens to process like 20%. Why do this again? And then they need to understand like a track record, like what we did before, what kind of application we ran before. They need kind of like a state of this to be efficient, not in production, but in their experimentation flow. So, okay, and we identify like 3 types of problems here. Incremental update, when data is changing, retry processing when data is failing, and data checkpoints to kind of be able to get back and start processing from some previous result. So let me show you quickly how it works. And by the way, I will be showing you, one sec. I will be showing these examples on DataChain, but those principles are pretty general. So it can be like used for, if you code this by yourself or using some different other tools. One sec. So that's how conceptually processing should usually looks like. You get the data somewhere, right, from some like bucket storage. You do some processing. In this case, just simple like extract metadata, right, for each file, like some metadata that we got from the file itself, and save some results somewhere. Very simple. But this process might easily take like several hours, a lot of tokens, and when new data came, you don't want to repeat this again. So you can hack it together and put like 20 lines of code, like how to save the previous state, right? See the difference, do the compute only on the different, then aggregate everything together, but the problem is you will get like a lot of this code like all across your base. But the good tool should handle this, right? Because that's such a fundamental thing. And what we have implemented for these types of companies and use cases, what we call delta update. When you can specify, that data is changing, next time you run, please run it only for the new data, on the new data, and combine result like after this result will be done, right? So in this way, you are saving like a day of processing. Instead of like a whole day of processing data from the beginning to the end, you process only like maybe 15, 20 minutes, right, the new data, and it goes to this new data set. And that's what people use like everywhere, like across the team, because that's such a simple and fundamental concept of dealing with the data that's you cannot like avoid doing this, right? So the other problem related to this failing. Okay, we do the processing, we do this efficiently, maybe like on several machines, maybe on several processes, using only like a new data. But what is if it fails? And it might fail like for a variety of reasons, right? Bugs in the code, LLM doesn't respond, which is happened when you do like like hundreds of thousands calls in a single day. Like of course, somewhere something goes wrong. And for this, we introduced like a special concept which we called like retry, when you can specify the kind of like a error column, and if some exception will be thrown in the middle of the process, you will see this in a special column. So next time you know like how to what to redo. So you have information about the failure, the reason why it failed, first, and second, you don't process like data that was already processed successfully, right? For example, here, that's how it looks like. Error right here, it's all the empty, right? But this one is get some error message. It's actually made up because I just made up this like use case and throw exception randomly. But that's something that can help save a lot of time for the team in terms of like reprocessing this data over and over again. And the third concept, data checkpoint, that's something that we'll be releasing soon. It's about using this concept of checkpoints. You know, right, the checkpoints from the models, right? You can train the models, generate checkpoints like over time, and when something goes wrong, you just return to like one of those and start from here. So the same principle should apply for the data, because your data can fail. It's not SQL. In SQL, you do like everything, like from beginning to the end in one query, and databases like do this like super efficiently. With a heavy data, that's not possible. You need to download data. There's a lot of reasons to fail. You need to process data, bugs, and etc. You need to run models or LLM, which can fail, and save the result, which can also fail, right? So the data checkpoint, it helps you to organize this process in a way that you can jump back and forth between these your data states. So visualization, I won't spend a lot of time here, but it's very clear that visualization is must-have part in multimodality. Researchers need to see the data. With tables, no problem. This modality is straightforward. You just look at the table. It's clear like what is happening. But when you work with the video, audio, etc., you need to see this, right? You need to see the image itself, like maybe here, right? Or you want to see, let me show you something more cool. PDF file, right? If your application returns some result about some company, you want to understand like how result is relevant to the actual source document at the end of the day. So internet is not perfect, but we will see. Yeah, here we go. So documents, right, when which was used as a source for this processing. And it applies to all different modalities, right, for the, let's say, scans different like 3D models. Do I have any 3D? No, not today. Sorry. But that's just one of the parts that you need to keep in mind. People need to see the data. So, and complexity of this data, it's all, it's something that makes, that requires a lot of time for team to kind of agree on. Let's take a look at one single video file. One single video file, it might be like, I don't know, 20 megabytes, right? Or maybe like a couple gigabytes. It looks like one entity. But in fact, in order to work with this, you need to split it by small clips, right? Because your models, your LLMs usually cannot handle the whole file. So you need to split it by like dozens, hundreds, maybe thousands of clips. Clips needs to be split by frames, maybe by second, maybe like 20 frames per second, maybe 1 frame per clip, but that's the way how you work with images in super powerful imaging model, right? Inside the image, there might be area of interest. People, cars, cancers, cancer kind of suspicious part of the cancer, right? Those not need to be presented in your data model, right? I'm not even mentioning like audio channel, which goes separately and usually requires like segments and spectrograms or whatever. But in one single file, you can easily have several thousands of objects inside it. And if you put everything to like one massive JSON, sometimes that's the not best way of like dealing with this, right? So I'll show you like how you can represent this better. But general idea is very simple. A lot of teams, like when they start like working with the JSON, that's very natural first step for majority of the team. They realize like, why don't we just introduce like some centralized database and put this information to database in a nice columns, and that would be like our source of truth about this meta information, right? So very fast, centralized. It's kind of like your caching layer, and that is going to, and in majority of the cases, that's the foundation for your like agentic workflow, because you don't want your agent like process your like frames and clips over and over and over again, right? It's better to cache this information in centralized place and then work with this, right? And that's how we organize this in DataChain. But majority of the team like do something like similar to this. Instead of JSON, they start using Pydantic, right? You probably know this like a pretty common format. All LLMs return result as a Pydantic project objects, right? So, and you can describe all this complicated structure within a Pydantic, right? Like in this example, let me show you something. Like a data model, right? YOLO, which has bounding boxes and segment and poses, and bounding boxes have a list of arrays with 4 floats and et cetera, right? But any level of complexity can be like supported by this, even LLM, right? LLM response is super complex in terms of data structure. And the job of the tool usually is to handle this properly. And these complex data structures should fit to these beautiful tables which your team is using, so you don't waste time on this like a SQL transformation and such, right? At the same time, you're getting all the benefits of this like a SQL power. So you write this in a Python with Pydantic and get all the benefits of the SQL. So you can efficiently, let me show you some use cases. Well. Yeah, like this. You can efficiently query this through like a data frame like APIs, or maybe go directly to the database and run it on, against the SQL engine. So for example, like how often do I see trucks in my frames, right? And the answer is like almost 2% of frames contain some trucks. Or how often do I see trucks but per video file, not per frame, right? And again, that's just another SQL statement or data frame statement, and you can find this very easily. And what is more important, you don't process the whole data, the whole file, the whole data set, right? So when you analyze and quickly iterate with the data, or when your agent does this job, right? That's the way how you can like be efficient. So in this way, we kind of like, we know very well how to deal with the structured like data and big data, right? But with the database in the center, we can kind of reduce, if you wish, the problem of a heavy data and multimodal data to the problem of structured data, the problem that we know like very, very well as an industry. So as you see, a lot of new challenges. A lot of companies wanna get benefits of their massive amount of unstructured data, but this whole new opens like a whole new universe of data practices, data engineering and AI engineering, and we need to learn how to do this efficiently with all the complexity we have around. But the opportunity of like dealing with all this like unstructured data and getting these benefits to the business, that's tremendous. I believe it will be like a way bigger trend, even if compare this with a big data and big data analytics, because LLMs can do like a way better and way faster to understand this data. Thank you.